Welcome to this YSL Excel VBA tutorial. This video is going to cover how to create pivot tables using an external Access database as its data source. So the video is going to focus primarily on creating connections to external sources and specifically to an Access database. We're going to look at how you can create a connection manually in Excel and then how you can write code to reproduce that connection, focusing specifically on the connection string and all the intricate little things you've got to do to make that actually work. When we've got the connection working, we'll look at how you can then base your pivot cache and then subsequently a pivot table on that external source. That's kind of the easy bit actually. We'll then look at how you can reference various elements of an Access database. We'll look at using an Access table as a data source, then how you can create an Access query to generate more dynamic results, and then finally how you can write your SQL queries directly in the VBA code itself. So we're going to teach you a little bit about how to write SQL queries as well. So quite a lot to do in this one. Let's get started. Just to get started, I'd like to do a quick recap on creating pivot tables based on simple Excel data. Now obviously we did this in a lot of detail in the previous video, but this will just give us a nice quick summary of the basic techniques and gives us a nice starting point for some of the more complex things we'll do in this video. So the first file you'll need to use is the same movies workbook that we used in the previous video, and I'll stick a link in the description below the video on YouTube and above the video on the YSL website so you can download this. So once you've got it opened up, you can head into the Visual Basic Editor, and in there we'll insert a new module, and the first thing we'll do is write a quick simple subroutine called Create Basic Pivot. The first thing we'll need to do is create a pivot cache, and this is true whether you're using an internal Excel data source or an external data source, as we'll do later on. So to help with that, I'm going to declare a variable called PC as a pivot cache class, and then I'm going to set PC equal to this workbook.pivotcaches.create. Now there are several parameters to fill in here. There's source type, source data and version. The first one is compulsory, of course, the second two are optional. So just to help with this, I'm going to write this across multiple different lines, and we'll specify the source type by naming the parameter and then choosing the correct one from the list. Now when you're basing your data on a single Excel table, then Excel database is the correct option to use here. Later on when we talk to an Access database, we'll be using an external source. But for now we'll use Excel database, and then I'm going to type in a comma to move on to the next parameter, and again stick this on a separate line, and I'm going to specify the source data. So this, in this case, for an internal Excel range of data, you can specify a range object. Microsoft's recommendation though is to create a string which represents the range of cells you're interested in. So the simplest thing to do here, I think, to make this as dynamic and robust as possible, is to use references to the WS Movies object. So I'm going to say wsmovies.name, and then I'm going to concatenate that with a exclamation mark character, and then concatenate that with a reference to wsmovies.rangeA1, get there eventually, .current region .address. So the address property returns the cell references as a string of text. So all this put together will form a string of text which represents the range of cells I want to use. The final parameter, version, allows us to specify exactly which version of pivot table we wanted. We talked about this in the previous video, so for this example I'm just going to accept the default version, which will be Excel pivot table version 12. So I'm not going to bother modifying that. At that point I'm just going to close the parentheses, and that's our pivot cache created. Just before I create the pivot table, I'd like to create a worksheet to put it on. So let's have another couple of variables to help with that. Let's go up to the top and say dim ws as worksheet, and then a bit further down we'll say dim pt as pivot table. To create the new worksheet, that's pretty straightforward. We can say set ws equals worksheets.add. Worksheets.add was what I was trying to say. And then that will both create a new worksheet and set a reference to it in the ws variable. And then we can also say set pt equals, and then we'll use a method of the pivot cache object. So we can say pc.create pivot table. Couldn't be more sensibly named, really, could it? So there are several parameters to fill in. I'm only going to fill in the first two, which is table destination and table name. So in this case, table destination, which is going to be, this is the only required one. You can see that because it's the only one that's not in square brackets in the parameter list. But the table destination is the top left-hand corner cell that your pivot table will begin at. And I want it to start in cell A3 of my new worksheet. So if I say WS range A3, that will put it in the at the top left hand corner will be range A3 on the new sheet, and I'll also give the table a sensible name as well, just to help with referencing it later on if I should need to do that. So I'm going to say table name equals movie pivot, and at that point we'll have created a basic pivot table, but it won't have any fields attached to it just yet. Now there are several methods you can use for adding fields to a pivot table, and we looked at several of them in the previous video. So just to do a quick simple example here, we'll say pt.addFields, and then we've got several options we can fill in here: row fields, column fields, page fields. So the simplest way to do this, I'm going to type in a space underscore, and then I'm going to say row fields, and I'm going to refer to one of the columns from my Excel workbook. So I'm going to refer to the Studio column first of all. That will form the left-hand column of my pivot table. So I'm going to say Studio, and then the column fields will be the next thing I'll specify. So that's column fields equals, and I'm going to make that equal to the certificate column. And then one more, the data fields, sorry, beg your pardon, the page fields equals, and then I'm going to make that equal to the country. Now technically we don't need to add any of the row fields, column fields or page fields, but just to help us to see what's going on with the pivot table when it's created, that's a nice basic arrangement. The final type of field we're going to add is going to be a data field, and this is what generates, of course, the actual aggregate values, the sums or the averages or whatever it is you've chosen. So to do that, we're going to say pt.addDataField. Then there's a couple of parameters to fill in. I'm going to specify first of all the field parameter. So here I need to reference a pivot field object. I can't just type in just the name of a column from the underlying worksheet. I've got to refer to an actual pivot field. So I need to say pt.pivot fields, and then from there I need to reference the correct one, which in this case I'm going to refer to the runtime column. So that runtime column refers to column D on the original worksheet. What I can then do is type in a comma and a space underscore, and I can also specify which function I'd like to apply. So I'm going to say function equals, and then to see a full list of all the available functions, I can say Excel consolidation function, followed by a full stop, and this will give me a list of all the available consolidation functions. I'm just going to use the average function for this example. One final thing I'm going to do is apply a number format to the results. So with an average we'll end up with quite a large number of decimal places. I want to limit that to just 2 decimal places. So to do that I'd like to apply a number format to my first data field. So I'm going to say pt.dataFields, then open some parentheses, and then I'm going to use the index number of 1. So the indexing of fields in a pivot table is based from 1. Then I can refer to the number format property. Sadly the IntelliSense breaks down at this point, but just bear with me, trust me on this one. You can say number format equals, and then in some double quotes you can enter any of your standard Excel custom number formats. So 0.00 will generate a basic number format with 2 decimal places. At this point, all I need to do is run the subroutine to generate the pivot table, and if I simply do that, we'll end up with a new worksheet sitting in the workbook. And if I have a quick look, we've got a fairly basic pivot table listing all the studio names down the left-hand side, certificate names across the top row, averages of runtimes in the data region, and a page field that allows me to filter all the results by the country. What we're going to move on to now is show you how you can do essentially exactly the same thing, but using an external data source. In this video is going to be an Access database. The Access database that I'm going to use for this video contains very similar information to what we've just been looking at in the Excel worksheet. If you want to get hold of a copy for yourself, then I'll stick a link in the description either above or below the video, again depending on where you're watching this video. And just to show you where that's actually going to come from, it's part of the Wisal website. We've got all of our course exercises available online for you guys to download and practice with, just in case you haven't got anything better to do with your weekends. It makes a change from watching these videos, I suppose. So the particular one we're going to go for here, just in case you need to copy the URL, but as I say, I'll have the link in the video's description anyway. You need to find the link that says this file. So if you click on that link, it will download that file. Now, depending on which web browser you're using, of course, that will present itself in slightly different ways. So in Chrome, it gives you a little pop-up at the bottom of the screen, which I can click on the arrow to open or show in this folder. And if I do that, it'll take me to my downloads folder and show me the zipped file that I've just downloaded. What you'll then need to do is right-click on that folder and then choose to extract it. And then you can click extract if you've chosen a particular sensible file path, and then the extracted version of the folder will contain a single movies database. I don't want to use this in my downloads folder, so what I'm going to do is copy this from here, or even cut it with Control X or Control C, and then I'm going to just head to the root of my C drive, and I'm going to create a brand new folder in here. So my new folder I'm just simply going to call databases, and then if I head into that folder I'm going to paste in the movies database, and that's the file that we're going to use for the rest of the video. So let's head back to the VB editor and look at how we can now create a connection to that external database. We can't actually query or create a pivot table on that database until we have a connection to it, and although we can create connections in code, it's slightly more convenient just for the purposes of demonstration to show you how to create the connection manually first of all. So what we're going to do is head back into the Excel workbook, and I'm just going to delete this worksheet that we've just created, and that's fine, I can choose delete. And what I'm going to do is head to the Data tab in the ribbon and choose the Connections option. So you'll find this in the Connections section. There's a Connections button somewhere sitting there. So if you do that to open up the dialog box, what you can then do is choose to add connections by clicking the Add button. Now once you've done that, you'll be presented with another dialog box asking you to choose which connection you want. If you've previously created connections on this machine, then you may well see some items in this list already, but I haven't, or at least I've deleted the old ones that I've created previously. So what I'm going to do here is click the Browse for More button. This lets you browse for either existing connection files, they'll have this extension ODC. What I'm going to do is actually browse to my Access database. So I put that in my databases folder. If I browse back again to the root of my C drive and then find my databases folder, there it is, and then find my Access database and just double click on that database. What I'll then get is a separate dialog box asking me to choose a particular table there. So this is a nice way to see what data, or what tables at least, are contained in that database. Of course we could have just opened the database up. We'll do that shortly just to see what's in there. So I'm going to choose my film table, which is called TBL film, and if I select that and click OK, I'll have a new connection called Movies available. And having done that, I'm just going to close down that window, and then I'm going to use this reference to this Movies connection to create the code that will connect to my Access database. Now the good news is that the basic structure of creating a pivot table based on an external source is exactly the same as doing it for an internal Excel source. So what I'm going to do is copy and paste this entire subroutine, and then we'll rename it, of course. We can't have two subroutines with the same name. Let's create a basic pivot from Access. Oops, no spaces in those subroutine names there. What we can then do is modify the source type first of all. So although technically we are connecting to a database, slightly confusingly, database refers to a database of data inside the Excel workbook, not external to that. So confusingly, we're going to change Excel database to Excel external. What we can then do is modify the source data. So instead of referring to a string of text which represents the range of cells, I'm going to remove all of that, and instead I'm going to refer to my my Access connection called Movies. Now one way to do this without using a variable is to refer to this workbook dot connections, and then open up some parentheses and refer to the name of the connection we've just created. So that was called Movies. So I can enter the word Movies there, and then close the double quotes and close the parentheses. Now it's also possible to use variables to refer to your connections, so just to make this code a little bit tidier and slightly more easy to manipulate later on, I'm going to declare a variable which holds a reference to the connection object. So to do that I'm going to head up to the top and say dim cn as. Now I'd expect to look for the word connection in this list, but sadly that's not quite the case. I've got a reference to the connections class but not connection, which is what I actually really need here. The particular type of connection we're looking at here is referred to as a workbook connection class. So dim cn as workbook connection, and then before we create our pivot cache, I'm going to say set cn equals, and then just copy and paste, or in fact cut and paste, this workbook dot connections movies. What I can then do is set the source data to be equal to cn, and that will make life slightly easier a little bit later on. The next thing we need to do is update the field names we've referenced, because the field names in the Access table aren't the same as those in the underlying Excel worksheet. So studio, certificate, country and runtime all need to be updated. The simplest way to find out what the column names in the Access database are is to open up the Access database, providing of course that you've actually got Access installed on your machine. So to do that, I can head to my Databases folder and then simply double-click the database to open it up. I'll then find there's a film table on the left hand side, and that's the table that we linked to. And I want to see that in design view, so I'm going to right click on the table and choose design view. This is just the clearest way to see the names of all the columns. So instead of studio, we've got film studio ID, we've got film country ID, we've got film certificate ID, and then film runtime minutes. So if I've found out what those column names are, I can happily close down the Access database, switch back to the Excel VB editor, and then I can update the names of these columns. So rather than studio, it's film studio ID, and then rather than certificate, it's film certificate ID, and then country is film country ID. Hopefully you're spotting a bit of a pattern here. And then finally, for the runtime, that was called film runtime minutes. Oops, excuse me, film runtime minutes. Okay, so those are the column names updated. At that point, all you should need to do is execute the subroutine to create the new worksheet and the new pivot table, and if I have a look back in Excel, I'll find that I have indeed got a new pivot table that's based on my Access film table. So I'll see that I've got the ID columns, as I've just pointed out in the Access database. The sad effect of that is that rather than seeing studio names and certificate names and country names indeed, what we have instead are the underlying ID numbers of those items. This is a problem we're going to solve shortly in the video. We're going to look at how you can actually get the studio name and certificate name and country name back into the database, or sorry, into the pivot table. This is a feature of the relational database nature of the data we're looking at, but we'll talk about that a little bit later on in the video. What I want to move on to next, if I can just delete this worksheet and this pivot table, what I'd like to move on to is looking at how we can create or write code to create those connections rather than having to do it manually and then reference one that already exists. So the next thing we'll do is create a new copy of this subroutine that doesn't just rely on an existing connection, it generates a new one from scratch. But we will use this one as the basis for the next example. So let's copy and paste the entire subroutine, and then let's modify the name, so it's going to be called something like create connection and pivot from Access. So let's do that, connection and pivot from Access. We'll keep all the variables we declared earlier on, but the main thing that's going to change here is the line which says set cn equals. We're not going to create it to be equal to an existing connection. What we're going to do instead is refer to a method of the connections collection. So we'll say this workbook.connections.add. Now, depending on which version of Excel you're using, I happen to be using Excel 2013 here. My add method is called add2. Yours may well just be called add. So in that case, just go along with whichever method you have. We won't do anything different. So at this particular point, I won't do anything that's unique to 2013 in this example. So I'm going to use add2 as that's what's provided for me. Then I can open up a set of round brackets or parentheses and have a look at what parameters I need to fill in. Now the first couple of parameters are relatively straightforward, just a couple of strings that have a name and a description for the connection. So let's just fill those ones in first of all. I'm going to give myself a continuation character, space underscore, I'm going to say name colon equals, and I'm going to call this connection Access film table, just to make things as explicit and obvious as possible. That's supposed to be a string, by the way, so that needs to be wrapped up in a set of double quotes. The description is something that somebody else reading the details of this connection could use to understand what it is. I think our name is descriptive enough personally, so I'm going to say description colon equals, and then make that equal to an empty string. It's a required parameter, you can't get away with not passing a value to it, but an empty string is perfectly valid. Now the next parameter is a really important one, the connection string itself. This is an incredibly tricky one. I'm not even going to attempt to write this out from scratch by hand. What I am going to do is just close a parentheses at that point and show you what a connection string actually looks like based on the connection that we've already created. So to do that, I'm going to head back into the Excel workbook, and from the Data tab in the ribbon, I'm going to choose Connections, and then I'm going to select the Movies connection that we created earlier on, and then choose the Properties button. That'll open up a dialog box showing you how this connection is configured. And the really important thing here is the definition page. If I select the definition page, then I'm just going to resize this dialog box just to make things a little bit more readable, because you can see, hopefully at this point, why I'm not even going to attempt to type out my connection string. Look at how long that thing is in the first place. So there are several properties on here that are worthwhile looking at. So we've had the look at the connection name, which we filled in earlier on. We call ours access film table. We could add a description, which again in this case is blank. The connection type is going to be quite important as well in a moment. We'll have to set the connection type shortly. But the connection string, as I said, is by far and away the most important part. Now sadly we can't just do a straight copy paste of this. There's several modifications we're going to need to make. But a copy-paste is actually a really good starting point. So if you set up an existing connection and then you choose to use that as the basis, that's perfectly acceptable. This is exactly the way I do things if I need to do this in the real world. Because typing these things out from scratch is, well, way too complex for me, way too many opportunities for typing mistakes. So all I'm going to do at this point is I'm going to select that entire connection string and then I'm going to copy that to the clipboard. Then I'm going to just cancel out of this dialog box and then close down the connections dialog box. Head back to the VB editor and just again back inside the parentheses of the add method. What I'm going to do, actually rather than using the add method to do this, what I'm going to do instead is use a separate variable to set up my connection string. So I'm going to create a new variable called cnString as a string, and then I'm going to say cnString equals, and then in some double quotes I'm just going to paste in everything that I've just copied from that dialog box. Now that will cause a bit of a mess. I'm not sure it will go into, it has all gone into one single line. That's quite handy actually. Okay, so there's a few modifications that we need to make to this to actually make it work, but that's a good starting point for generating a connection string. One important addition we have to make to the connection string is to state what type of connection string it is. Now this isn't something you have to do when you build the connection string using the dialog box, but when you're doing it in code it's important to state that this is an OLEDB connection right at the start of the string. This is to distinguish it from other connection types like ODBC for instance. This one's definitely an OLEDB connection. You can see that the provider we're using is an OLEDB provider. So that's the first important thing to change. The other really important thing to do is identify in this entire connection string anywhere where it's trying to pass in an empty string to a property. So if I just scroll along a little bit, the first one that I encounter here is called extended properties equals double quotes double quotes. So what that's trying to indicate is that it's trying to pass an empty string to that property to create the connection string. The problem with that is that double quotes in VBA are already symbols that are string delimiters. You can't just indicate double quotes in a string by using two double quotes. That doesn't work. Just to demonstrate, try to demonstrate what I mean by that. That's not a particularly good description. If I press Ctrl and G on the keyboard to display the immediate window, if I write in something quick and simple like question mark, then open up some double quotes and then say wise owl and then close the double quotes. If I hit enter, that's going to type in the text wise owl. So notice it doesn't include the double quotes. The double quotes are the string delimiters. If I click somewhere inside that string and I enter a double quote, then again, that's not going to print out that double quote and it doesn't print out anything after it either. If I enter two double quotes and then click at the end of the line and press enter, you'll see I get a single double quote in the line. So everywhere where we've got a pair of double quotes in the connection string, that's actually only going to generate a single double quote, if that makes sense. So the slightly irritating thing we have to do is to put 4 double quotes in a row, and if I do that and press enter, that'll come out with actually 2 double quotes in the final output string, which is a bit tedious. Another choice here in this particular case, you could just delete the double quotes altogether. Since that passes a null, I believe, to the connection string, that's also acceptable. But in this case, what I'm going to do is find every pair of double quotes in this string and then just double them up. So I'm going to have 4 double quotes for every pair. So make sure you get them all in this case. There aren't actually all that many. And hopefully we're just about there. New database password. Sadly, all these extra parameters, all these extra attributes are actually necessary for this to work. So you can't just get away with deleting all this extra stuff. All these options are required for the pivot table and the pivot cache to work. So That looks like I've got all the double quotes, or the double quotes, which should be quadruple double quotes at this point. And having done that in my connection string, there's just a couple of extra properties to set of the connections object. So let's just modify the code that where we're using to add the new connection. I'm going to give myself a continuation character so I can specify each parameter on a different line just to make things look a little more readable. And we've added a description, which is an empty string. The next thing to do is specify the connection string. We've just spent all that time building it. We might as well actually reference it. So connection string equals cn string. Then another comma, space underscore. The command text, this is also pretty important. The command text in this case is going to be the name of the table that we're trying to reference. So earlier on when we built the connection using the dialog box, we pointed to one specific table. So we need to pass in the name of the table that we're referencing, which is TBL film in this case. Then one more that we can do here as well, we can specify the command type. This is going to become a little bit more important later on in the video, but for now I'm just going to specify, slightly weirdly, the name of the parameter is L command type, and I can't help but feel that's a typo with whoever developed this particular method. LCMD type is the name of the parameter. I think that's a bit of a typo. I think that should have been XL command type, but anyway, the values you're allowed to use to specify this parameter are all constants in a particular enumeration, and the reason I think it was a typo is because the enumeration we're going to use is called XLCMD type. And if I enter a full stop there, there's a great big long list of different options. Now depending on which Excel version you're using, you may not see some of the items in this list. For instance, DAX. If you're using an earlier version of Excel than 2013, you may not find that in your list. We're not going to use it in this video anyway. All we're going to do is specify that this command is a command table. So I just suggesting that that's, or specifying that that's the name of a table, not a SQL command or anything else. Okay, so having done all of that, that's basically the connection set up, but we've done it now in code rather than manually. So our original connection called movies could happily be removed at this point because our new pivot table, our new pivot cache, is going to use the new connection that we've just generated. And just to demonstrate that that's going to work, let's give it a quick test by running it, and we ought to end up with a new worksheet which has got a list of all the columns from the film table, but this time using a connection that we've built ourselves. And if we click on the connections page, we should find that we've now got a new connection which is called access film table. Now one thing to watch out for with creating connections like this is that if the connection already existed and you try to create it again, your code wouldn't be prevented from working. Let me just close down the connections dialog box and then head back to the VB editor. And I'm just going to run this exact same subroutine again just to demonstrate that if I do that once, maybe twice, maybe 3 times, if I then switch back to Excel and have a look at the connections page, I've got a new copy of that same connection for every time I've run the subroutine. Now usually this is sensible behaviour because it means that each individual pivot table can use its own individual connection, so that if one connection gets either modified or deleted, it won't affect any of the other pivot tables because they use their own separate individual unique connections. Just in terms of tidying up for this video though, I think it makes sense to write a couple of quick utility routines at this point. One that's going to delete all the worksheets except for the movie sheet, which we've done in the previous video of course, and then one that's going to delete all of the connections as well. So that includes the original movies one that we created. Unlike with pivot caches, if you delete a pivot table, a pivot cache is also deleted if it has no further pivot tables using it. But if you delete all the pivot caches which use a connection, the connection itself isn't deleted, the connection remains. So we'll have a couple of routines that will delete all the sheets and then all the connections just to keep things neat and tidy. So if I close down the connections dialog box, let's head back to the VB editor, and I think we'll create a separate module for these two simple basic routines. So let's just do that right now, and then let's create a couple of these extra routines. I'm just going to close down the immediate window as well at this point, and then let's have a quick subroutine first of all called delete all but movies sheet. And we did this in the previous video just as a quick simple way to tidy up after ourselves. We can use a WS as a worksheet variable, and then we can say for each WS, I'll get there eventually, each WS in this workbook dot worksheets. Next WS, I'm going to say if not WS is, WS movies, which is our original, or the code name for our main list of data, WS movies, then ws.delete. And I want to make sure that when I do this, that the alert messages don't appear as they ordinarily would. Are you sure you want to delete this? So I'm going to say application.displayAlerts equals false. So that will make sure that I don't see those little pop-up messages. Now at that point, if I were to execute that subroutine, I'll see all my worksheets except for the movies sheet disappear. Just going back into Excel, that means that I don't have any more pivot tables in this workbook, which means that I don't have any pivot caches either. If I switch back to the VB editor just temporarily and maybe display the immediate window again, press Ctrl and G, I'll just clear its contents out, Ctrl A and delete. If I say question mark this workbook dot pivot caches dot count and then hit enter, I've got 0 because I don't have any pivot tables. If I change that to say this workbook.connections.count, however, I'm going to find that I've still got all the connections that I previously had, so all 5 of them. And it might be important to get rid of those. You can see them again from the data tab and the connections page. They're all just still listed there. So what I'm going to do next is to write a routine that's going to do the same thing but to delete all the workbook connections. So the process is essentially the same as the loop to loop of the worksheets. Let's have a new subroutine that says delete all connections, and then we can say dim cn as a workbook connection, and then say for each cn, excuse me, I can't spell each, for each cn in this workbook dot connections. So although the class of object is a workbook connection, the collection name is just connections. We'll say next cn, and then inside there all we're going to do is say cn.delete. We won't see any warning messages for deleting connections, so there's no extra code to write here. If I then just execute that routine and then click back into the immediate window and hit enter at the end of that line, I'll find out that I now have 0 connections. And again, you can prove that of course by heading to the back to Excel, opening up the connections dialog box and finding that they're all gone. Okay, so we've written code that will explicitly create a connection object with a unique name that we give it, but it's also possible to create pivot caches without explicitly creating a connection. If I switch back into module 1, I'm just going to close down the immediate window as well. What I'm going to do is make a copy of this entire subroutine, the last one that we wrote, creating a connection and a pivot from access. I'm going to copy the entire thing and then paste it in just down below. I'm going to say something, I'm going to change its name so it says something like create implicit connection and a pivot from access. And in this example we're not actually going to need our connection variable. I'm going to leave it in there just for the moment. We do need the connection string, but what we don't need to do is set our connection equal to the result of the add method for the connections class, or connections collection, beg your pardon. I'm going to select all that code and just remove it entirely. I then just need to make a small change to the way the create method of the pivot caches collection works. So rather than specifying the source data at the point I create the cache, I can remove that parameter altogether. That's it's an optional parameter. I'm absolutely fine to do that. And I'll just tidy up a little bit here as well and put all this onto a single line now. So rather than specifying the source data at that point, what I can do instead is after I've created the pivot cache, I can say pc.connection, and I can make that equal to a connection string. So cn string. I can also modify the command type and command text as we saw in the previous examples. I can say pc.command type and I can make that equal to, and I'll get my actual list this time. I don't have to refer to the command types enumeration. So that was a command table. And then I can also say pc.command text, which is the name of the table I want to use. So I say pc.command text and then set the text to tbl film, and then that's essentially all I need to do. So at that point, of course, I haven't actually created a connection object, and I've never referenced the connection object anywhere. If I just comment out that variable just for the moment, and then we can find that we can run this one and create a new pivot table with an external connection to an Access database without explicitly creating a connection at all. Now, of course, the connection has to exist, it's just that it's created for us implicitly. So back on the Data tab in the ribbon, I can click on the Connections page, or Connections button, and it generates a new generically named connection called just simply Connection. If I look at its properties, it will have on the definition page, of course, the same connection string that we set up earlier on. You see its type is an OLEDB query, its command type is table, its command text is TBL film. So we just set up all these properties, and the connection object gets created for us. Now, one small problem of using implicit connections is that you don't know what the name of the object that's being created actually is. But that's not actually that big a problem. If you need to reference the connection of a pivot cache or a pivot table, then you can get that information fairly easily. Let's say, for instance, you needed to refresh the connection to bring in the most recent data, or refresh the pivot cache indeed, or the pivot table. So to do all of that, what we could do is get the connection object of an existing pivot table. So if you accept that we've got, in this case, sheet 7 open at the moment, I'm just going to refer to this as the active sheet. What I'm going to do is head back into the VB editor and create a brand new procedure, a brand new subroutine called sub get reference to connection. I'll spell that properly as well, with a lowercase e rather than a capital. We'll use 3 variables in this example. They're not all necessary, but it just helps me to write the code a little bit more neatly. So I'm going to declare dim PC as pivot cache, first of all, dim PT as pivot table, and then I can declare one final variable, dim CN, as a workbook connection. What we can then do is start to get references to all of these objects. So to begin with, let's say set pt equals, I'm going to assume that I've got sheet 7 selected, so I'm going to say active sheet dot range A3, which is the top left hand corner cell where I put my pivot table earlier on. Then a range object has a property called pivot table, which indeed returns a reference to the pivot table that that cell belongs to, so it's pretty straightforward. I can then say set pc equals pt dot, and then a pivot table has a method called pivot cache, which of course returns a reference to the pivot cache on which that pivot table is based, and you're probably getting the idea at this point. I can then say set cn equals pc dot, and then the particular property of this is called workbook connection. So that returns a reference to the connection object on which that pivot cache is based. Now, the neat thing about this is that I can make any changes to that connection object that I like now. So I'm going to use a with block to make a couple of very basic changes to the connection object. I'm going to say with cn dot OLEDB connection. So we talked about OLEDB connections earlier on, and the type that we created was definitely an OLEDB connection. I'll add in the end with, and then I'm going to make 2 really simple changes. I'm first of all going to change the command text property to be equal to a different table. So we've used the film table a couple of times already. This time we're going to use the actor table. It's a much simpler table. It's just got essentially actor names, dates of births and genders. But what we're going to do is count how many actors there are of each gender in a new pivot table. Or in fact the same pivot table, just modified. So we can change any other property of the connection. I'm just going to show you that you can also change the command type in this case, so the command type can be equal to any of these command types. We will get into different command types shortly, but for this example it's still going to be a table. I don't technically need to change that because the command type itself hasn't changed, but just to demonstrate that it's possible to do so. What I then need to do is refresh my connection to update its field. So I can say cn dot refresh, and that will update all of the fields that it has access to, which of course at that point will completely destroy the pivot table we're working with. So I've got a completely new table, which means it won't have access to the film runtime minutes and the studio and the certificate, etc. So what I need to do next is build up the pivot table again with new fields. So I'll say pt.add fields, and I'm only going to add in a row field this time, and the row field is going to be the actor gender ID. I can then add in a data field below that. I can say pt.add data field. And the first field I'm going to use here is going to be pt.pivotfields, and I'm going to use the actor ID, which is just a number. It's an identifier number. It doesn't represent a quantity of anything. And having done that, I'd like to specify that the function I'm going to use isn't a sum or an average. That would make no sense. I simply want to count them. So I can say consolidation function dot Excel count. Now at this point all I need to do is run the subroutine to make the changes, but I want to see that happening bit by bit. So let's just restore down the VB editor window, and let's just reorganize the positions of all these windows so I can see things a bit more clearly. So at the moment you can see on sheet 7 we've got our film table being used as the source for the pivot table. If I use the F8 key to slowly step through, I'll get references to all of the objects, and then I'm going to make a couple of changes to the connection. So you'll see at this point when I change the command text to refer to a new table, it does indeed update that, but it hasn't changed the connection object itself yet. So I set the command type, it's still an Excel command table at this point. It's the point at which I choose to refresh the connection that the pivot table will lose access to all of its current columns. If I hit F8 on that line, you'll see the entire pivot table disappears. If I just click back into the pivot table, you should see that it's now got access to the columns from the add table instead. So just going back to the VB editor, I can step through using the F8 key. I can add in the gender field. It's a gender ID, so again it's an identifying number for the gender. And then if I hit F8 again to add in the data fields, it shows me that I've got 86 of gender 1 and 254 of gender 2. So that's the basics of getting references to existing connections for existing pivot caches and then updating and refreshing them. Okay, so I'm just going to go back to module number 2 and tidy things up a little bit. I'm going to run my delete all but movies sheet and then delete all connections. And then I'm just going to have a quick look again back in module number 1 where we created a pivot table based on our film table from the Access database. I'm just going to run this subroutine one more time just to generate that base pivot table and have a look back at the Excel workbook just to have a quick look at what we get. So connecting to a single table in an Access database works reasonably well. We can see that we can get the data, but it doesn't provide us with much in the way of useful information about categories of information. This is purely to do with the structure of the database we're using. It's a very standardized relational database where rather than storing the name of the country and the name of the studio and the name of the certificate in the film table, what it does instead is stores the ID numbers of those objects so that they can be looked up and returned back to any queries that we write. Now the problem is, of course, we've only connected currently to the film table, so we're only going to get access to the values, the numbers stored in that table. What I'd like to do is show you a variety of different ways now that you can actually get access to the other tables and essentially return data from more than one table at the same time. Now, one really simple way to get access to multiple tables in the same connection to the Access database is to actually write a query in the Access database which we can reference in place of just one of the base tables. So that's what we're going to do. We're going to learn a little bit about how to write queries in Microsoft Access, but we do have a small problem with being able to do that right at this point in time. If I go back to my databases folder and I attempt to open up my movies database, I'm going to find that I get a little warning about the database being open read only, so I can't make any design changes to it at this point. I'm going to close down the Access database and then show you why that's the case when it finally does actually close down. Let's close it down from the taskbar instead. There we go. So let's have a look back in our code at what's actually triggering this or causing the read only. If I just run my routines to delete the movies sheet and then delete all the connections, just to prove that it is our code, our connection objects that have caused that problem, having deleted all of the connections now, if I go back to the databases and open up that database again, I won't get the warning about it being open read only. So that's fine. So the problem clearly, definitely is to do with the connections we've created. If I switch back into module 1 and have a look back at the previous one to last routine we wrote together, so not getting a reference to an existing connection, but the one where we created an implicit connection from the Access database. Looking at the connection string, there's a parameter here called mode, which if I scroll along so I can actually read it, there's the mode property set to share, deny, write. So that means that it can be opened by multiple users, but the multiple users are denied from writing anything to it, so they can't modify the design. Well, we don't care about modifying the design at all in this particular workbook. All we're trying to do here is read the information to generate a pivot table from it. So what we're going to do is change the mode for this connection string, so not share, deny, write, it's just called read. You can do that for all of the previous connection strings as well if you like. It's a little bit of effort to go through and do that, of course, but it might be worthwhile having a quick think of doing that at this point, just to avoid any future problems if we copy and paste any code later. So just those two connection strings. If I can now just demonstrate that that will actually have the desired effect, if I go back to my create implicit connection routine, and then I can run that one, and of course it will generate a new pivot table on a new worksheet. But back in the databases folder, if I were to open up the database I find that it's opened up and I don't have the information about it being read-only. Okay, so here's the basic idea. I want to create one single query object that joins all the related tables to the film table, giving me access to things like the director name and country name, etc. So to do that, I'm going to head to the Create tab in the ribbon, and when that does finally appear, I'm having some slight issues here. I think it's to do with my screen recording software not liking Access very much, but if I can actually finally switch on to the Create tab in the ribbon, I'll get there eventually. There we go, and then I can choose to create a new query in Design View. So if I choose New Query in Design, I get access to all of the available tables. So I'm going to just insert a few of these tables. I'm going to go for the certificate table by double-clicking on that, then country, and director, and film, and language, and studio. And it just doesn't like the studio table right at the very end there. If I can just get the studio table inserted, there it is. Okay, I can close down the show table window at that point. If you've inserted a table that you didn't intend, you can just right click on it here and choose to remove the table just in case. And hopefully you can see in the background here that we've got this indication that all these tables are related to the film table. So what that means is that I can add in fields from multiple different tables and they'll all come out with sensible information. So let's have a quick look. I'm going to go for let's go for the film table first of all. I'll have the film name and the release date, and then the film runtime minutes, and the budget dollars, and the box office dollars, and the Oscar nominations, and the Oscar wins. It's worthwhile only including the columns that you actually want in a query. Don't just include everything randomly. It's always worthwhile just being specific about columns. Then for each of the other tables, I'm just going to go for the name column. So double click certificate name, then country name, director name, language name, and finally studio name as well. I'm not going to go into any more detail about designing queries. There's many more things we could do here with an Access query, but just for the sake of demonstration, that's more than enough. What I want to do at that point is save the query. So if I hit the Save button, and again, wait for my screen recording software to recognise the fact that I'm clicking on that Save button. I could also just hit the Control S keyboard shortcut, and then I'm going to change my query so that it's called Film Query. If I then click OK, that will save that new object as part of the database. Just to see what results that gives us, if I hit the Run button on the toolbar, that should run the query and show me all of the data that it returns. But this isn't showing me the underlying number behind the language column and the director ID column, etc. It's giving me the actual textual values. So I can close down that query and then close down Access, and then if I switch back into Excel, I'm going to go back to the VB editor now and we'll write a subroutine that creates a connection to that query object to give us more useful information. Now the absolutely great news for us is that we've effectively done all the hard work already. Connecting to a query in Access is just the same as connecting to a table effectively, so the command type is the same. So we could legitimately copy any of our previous routines that create a connection to the film table. I might as well just go for the one that creates the implicit connection, as that's the one I'm looking at right now. If I just copy that entire procedure and paste it in down below, right at the bottom of the module, and then just quickly update the name of it. Let's say create connection and pivot from Access query, just to give it a slightly different name. Okay, so I'm going to get rid of my connection object there as my variable. I don't need that anymore, and then making sure that it's a read mode rather than a share deny write mode, as we've just seen. That can be a bit of an issue. What I then need to do, and simply all I need to do, is change the command text from film to film query, which was the name of that query that I just created. That does mean, of course, I'm going to have to change some of these field names as well, because I didn't include the film studio ID. What I did instead was I included the studio name column from the studio table. So I changed that to studio name. Likewise, I chose the certificate name column, so I'll change that to certificate name. And finally, country name rather than film country ID. So country name. The film runtime minutes column was the same. So having done all that, all I should need to do now is run this subroutine and I'll get a new pivot table. But this time it's connected to and returning information about the studio names, certificate names, and indeed the country names as well. So that's much more useful. Now that technique's obviously pretty useful, but it does of course require either you or somebody else to create the queries in the first place. So for the next thing we're going to do, we're going to cut out that step. We're not going to generate queries in Access. We're going to write some code in our Excel VBA subroutines that will generate the results of the query for us. You may remember from a previous video in this series, way back, when we looked at creating connections to both Access databases and SQL Server databases using something called an ActiveX Data Object connection. If you haven't watched that video, just to quickly point you in the right direction, because there are some really useful things in that video that you might find handy for this one. So way back in part 30 of this Excel VBA introduction tutorial series, there's a bunch of really useful information in there that will help you with some of the things we're about to do. It will also help a lot if you know something about the SQL language, Structured Query Language, which is what we're about to start writing. If you don't know much about Structured Query Language, then I'm going to show you a way that you can also essentially just steal it. You can get access to generate the SQL code for you and then just copy it directly into your VBA code. But just to get started, what I'd like to do is copy the last subroutine that we wrote together into a new module actually at this point. So the create connection and pivot from access query. Can you create a new module and then copy that subroutine into there? We'll update the name of this, so we'll say something like create connection and pivot from access SQL. And then we'll look at how we can actually use an access query to get some SQL code for us. So if I were to just start by going back to my Access database and then double clicking on that to open it up, if I then have a look at let's have a look at the SQL code of our existing query, film query. If I right click on that query and then choose to open it in Design View, there are several views of a query. We've looked at the Design View and the Datasheet view. Up in the top left hand corner there's another list of views you can see, and the important one for us here is the SQL view. If I choose that, now not particularly readable because the font size is so ridiculously small, but this is a select statement, a SQL select statement that will return all the results we've asked for. So the nice thing about the query designer in Access is you don't need to know anything about the SQL language at all. You design everything in a lovely little GUI tool and drag and drop and double click on things to generate your queries. But what's really stored behind the scenes, what that designer is really designed to do, is to generate this code. So we could, if we wanted to, just select and copy and paste all of that code directly into our VBA code. So if I selected that and copied it to the clipboard, I can then close that down and then close down Access. And then, back in this procedure that we're just writing here, what I'm going to do is set my command text not to refer to a specific named object, but to be all that SQL code. So I'm just going to paste over the top of where it says film query. I'm going to paste in all the text that I've just selected. Now of course that makes a bit of a mess because I've copied it across multiple different lines. So I need to do a little bit of tidying up. So the final closed double quote there, I need to backspace that onto the preceding line, and then right at the start of that line I'll need to backspace that onto the previous line as well. I'll need to get rid of that extra double quote that was added on automatically and replace that with a space, and then if I can have a quick look at that, that looks reasonably sensible. The other thing that we'll have to do, of course, here as well is that now this isn't a reference to a table, so I need to change the command type. Unfortunately, there is a command type designed for this. It's called Excel CMD SQL. So all we should have to do at this point is run the code to generate a new pivot table based on the result of that select statement. If I head back to the Excel workbook, I've got yet another new pivot table based on that SQL query. So this means that you don't have to go back and forth between Access unless you need to copy and paste SQL code, of course. If you're not familiar with writing SQL queries, then all you need to do is write your code directly into your Excel VBA subroutines. Now the main reason that this technique is useful is that it's very easy now to write dynamic flexible queries based on just concatenating a string to return the results you want. It helps of course a lot to understand how the SQL select statements work, and as I say, the video that I pointed out earlier on gives you a few ideas of the sorts of things you can do, and we do also have a complete video tutorial series just on writing SQL queries. If I can just briefly point that out, there's a playlist here called SQL Server Queries. So admittedly this uses Microsoft SQL Server rather than Excel VBA and Access, but the syntax in SQL Server is very similar to Access's syntax. Just enough differences to trip you up from time to time, but it's a nice starting point. And of course you could always just start designing queries in Access's Query Designer and then copying and pasting the code generated into your VBA code and then making changes to it in there. What I'd just like to quickly do is show you a couple of basic things about writing select statements. So I'm just going to quickly tidy things up a little bit by heading back to module number 2 and deleting all but my movies worksheet, and then deleting all of my existing connections. Then back into module 3, I'm going to make some changes to this particular subroutine that allows me to generate and show you lots and lots of different select statements. So here's what I'd like to do. Rather than setting the command text to be this explicit string, what I'm going to do instead is declare a parameter for this subroutine. So I'm going to say something simple like SQL string as string, and then in the subroutine itself, rather than using that really great big long-winded string of text, I'm just going to make the command text equal to whatever string I've passed in. That makes it nice and easy now to generate lots and lots of different examples by writing a few different subroutines down below. So let's have a quick extra subroutine down here that we're going to call test SQL queries, or SQL, SQL queries will do. Each time I run this one, I'd like to make sure that I've deleted all of the existing worksheets except for movies, and I've deleted all the existing connections as well. So I'm going to make a quick call to the delete all but movies sheet routine, and then also the delete all connections. I'm also going to have a variable here simply called str as string, just so that I can build up my string in a variety of different ways. Let's start with a really basic select statement. I'm going to set my str variable to be equal to select star or asterisk from TBL film, and then close the double quotes and then hit enter. Now this is pretty poor practice actually, selecting star. The asterisk here represents every column from that film table. This is the sort of stuff that DB admins tear their hair out over. You should really never select all the columns. You should always be explicit about exactly which columns you're selecting. Only choose the columns that you actually want. So this is purely for demonstration purposes, just to demonstrate the how things are related in terms of these routines at this point. In the real world, don't do that. What I'm then going to do is call on the previous procedure I've written, which is create connection and pivot from Access SQL. Should we give that a shorter name? Let's call it something like create Access SQL. Give it a slightly shorter name to work with. And then down in the code here, in our test SQL queries, I can say create Access SQL, and I can pass in my SQL string by saying str. Now of course I've got to make sure that the query, or sorry, the fields that I'm adding in the other procedure have access to all the fields that I passed in. So I haven't got studio name anymore, I've got film studio ID and film certificate ID. So I just need to quickly update this at this point. So let's just change those to film studio ID and film certificate ID, and then of course the film country ID as well. But once I've done that, I will be able to call that routine, passing in that simple string of text there to select all the columns from the film table. So if I were to run that one, I'll end up with a new worksheet, and it will have, essentially we're back to that same point where we've got the ID numbers of all those columns. But that's a nice starting point. That's the basics of a simple select statement. Now ideally what we should be doing is writing out the individual column names that we want to use specifically. So I'm only using 4 columns in this entire pivot table: the studio ID, certificate ID, country ID, and film runtime minutes. And really we should write those out explicitly. So rather than saying select star or select asterisk, I should say select film country ID, comma, film certificate ID, comma, film studio ID, comma, film runtime minutes. Now of course you have to be incredibly careful with this, that you spell all the field names exactly as they're written in Access. It's not case sensitive, by the way. SQL Server or SQL as a language isn't case sensitive. It's conventional to write the keywords select and from in uppercase letters, but everything else you should just match case based on how they've been created in the database. But I could have written this all in capital letters or all in lowercase letters and it still would have worked. So if I execute this one again, it will delete my existing sheets and connections first, and then generate a brand new one, and hopefully the end result of that will be exactly the same as what we've just looked at. But the key thing here, hopefully you can see, is that the pivot table field list this time only shows me the fields that I've selected in that query. One of the other nice things about a select statement is that you can add something called a where clause to it. So a where clause allows you to add filters to the data. So let's say, for example, I only wanted to see this information, this summary pivot table, for films which had won at least one Oscar. So this is going to get a little bit more complicated, so I'm going to start breaking up my string onto multiple different lines. So I'm going to have string equals select all the column names on one line, and then close the double quotes at the end, ensuring that there's definitely a space after the end of the column name there. Then I can concatenate that and use a space underscore continuation character and have the from clause on a separate line, and I'm going to add in a space at the end of that as well, and then another ampersand at the end and a space underscore, and then inside there I'm going to add another line. This is going to be a where clause, so I'm going to say where film Oscar wins is greater than or equal to 1. I could have said greater than 0 as well, I suppose, here, of course. But a where clause essentially lets you write criteria, and they're fairly similar criteria to the sorts of things you'd expect to see in Excel, using the standard comparison operators, greater than or equal to, less than or equal to, etc. So if I just have a quick look back at the list of data I've got at that point, you can see it's quite a long list of rows. It goes down to row 43. If I exclude all the non-Oscar winners from this list, that should be a little bit different. So let's have a quick go at running this subroutine and then have a look back at the results we get back on my new worksheet. And that's a much shorter list of data. So that's only based on films that have won Oscars. Your criteria can be based on any column and any data type in your underlying database. So for instance, if I wanted to include a criterion on the film release date, let's say I only wanted to show data for Oscar-winning films released since the year 2000. My where clause needs to be a little bit more complex than that, of course, so I'm going to say where film Oscar wins is greater than or equal to 1, and film release date. In this case I'm going to say greater than, or greater than or equal to in fact, and I'm going to refer to the date that is the 1st of Jan 2000. Now in Access, dates are enclosed in hash symbols, or pound symbols I guess. Do you call them in the US pound symbols? We call them hash symbols anyway. So the date I'm going to type in, to make it unambiguous, I'm going to type it in as 01, representing the day of the month, and then Jan, which is completely unambiguously the month of January, and then the year 2000. The reason I'm doing this is because, sorry, beg your pardon, that's a hash symbol rather than a single quote. The reason I'm doing this is because sometimes dates are treated ambiguously. If I said 5/12 2000, would that be the 5th of December or May the 12th? That's kind of a little bit ambiguous, so this one is completely unambiguous. So let's have a quick look at running that one. If I execute that subroutine this time, I should find a slightly different list yet again. So this is the Oscar-winning films that have been released since the year 2000. If I wanted to make my criterion based on a date range, then I can do something slightly clever here. So I could take away the greater than or equals and replace that with a reference to the between operator. So where film release date between 1st of Jan 2000 and let's go for 31 dec, let's say 2002. Sorry, not 2022, 2002. So what that will do, hopefully, is show me all the films released between those two dates and have won at least one Oscar. So if I were to run that one, I ought to end up with an ever decreasing list. If I change the date range again, so I've got 12 rows there, if I change the date range again to the year 2000 this time, so I'm only looking at data for one single specific year. If I run it again and have a look, I've got a very, very short list this time. So you can see how you can reduce and sort of make these criteria much more specific by writing multiple criteria. When you're doing that, it's sometimes worthwhile, sometimes it's necessary, in this case not, but sometimes it's necessary to enclose different sets of criteria in sets of parentheses. So just like you would in Excel, I suppose, in Excel functions, you can group together related criteria using parentheses. That will have no effect on this particular one. It'll end up with the exact same results. And again, I've talked about this kind of idea more in detail in some of the other videos, the SQL queries series and perhaps the ADO video as well, the one that I pointed out earlier on. One thing that's a little bit more tricky to work with in queries in where clauses is the text data type. So the way you handle text, if you're looking for an exact match for your text, it's not too big a deal. So in fact, let me just quickly show you that. If I copy my string code there. I'm just going to comment out that existing one and then paste in a new copy of this. Then what I'm going to do is take away all the criteria to do with the Oscar wins and dates, just to focus on the text part. So I'm going to ask where the film name is equal to. I'm going to look for the film King Kong. There should be a couple of instances of King Kong in the list. Now the thing that I've done here, Access will accept double quotes to enclose its strings. But remember the issue we had earlier on, where if you want to include a double quote in a string in VBA, you've got to double up the double quotes. So a neat way to solve that is that standard SQL code uses single quotes to delimit strings. So you can just use single quotes to enclose that string of text. Now I'm pretty sure there's at least one King Kong film in the list. If I run this one and then have a look at the results, yeah, okay, cool. So there's actually 3 different King Kong films in the list. So that gives me data for all the films that match exactly that film name. So there are exactly 3 films with exactly the film King Kong, or the name King Kong. If I wanted to do something a little bit more intelligent, like let's say find all the films that begin with the word King. So what I'd need to do to make that work is take away the end of that string, King, and then add a wildcard character. Now in Access, in Excel terms in general, in Microsoft terms, the wildcard character is an asterisk, but in SQL the wildcard character is actually a percentage symbol. So that percentage symbol there represents any number of any characters. I can't then use the equals operator to test if something is equal to King%. I've got to use a different operator called like. So where the film name is like King%, if I were to execute that subroutine at this point, I ought to end up with 4 films, I think. Yeah, I've got 4 different results this time. So 3 King Kong films and 1 Kingdom of Heaven is the other one. There's also a film that ends with the word King in my database. Feel free to go and check that if you like. By the way, you can just happily open up the movies database to check all these results. If I wanted to find any film that contains the word King anywhere in its name, then I can just use multiple percentage symbols. So basically that means to show me any film that begins with any sequence of characters and finishes with King, or ends with any sequence of characters and begins with King, or has the word King surrounded by any sequence of characters on either side. So if I were to run that one this time, I ought to end up with 5 different results, this time 5 individual values. So these represent 3 King Kong films, Kingdom of Heaven, and I think the last Lord of the Rings films, Return of the King. So there we go, there's a little bit about working with text. Now the most awkward part of all to get right in a SQL query is if you need to bring in multiple tables, how you join those tables together. You'll get a better idea about this if you use the query designer to join multiple tables and then look at the results of the code. Just to show you the absolute basics of how this works, I'm going to show you how to write a SQL statement that joins together, first of all, just the film table and let's say the country table, so we can get access to the country name. So to make that work, I'm just going to again just comment out, in fact let me just copy this part of my string first of all, and then I'm going to comment out what I've written there and paste that query back in again a little bit further down, and then I'm going to modify the from clause. So I've got my film table brought in. What I now need to do is join that to the country table, and the way to do that in SQL is to write something called an inner join. After the words inner join, you can specify the name of the next table, so that's going to be TBL country. What you then have to do, we're by no means finished yet, what you then have to do is specify which 2 columns those tables are joined on. So I'm going to say on TBL film dot film country ID, so you reference the table name followed by the column name. That's not always necessary. If your column names are unique between different tables, then you don't need to do that part, but by convention you do it anyway. So we'll say tblfilm.filmCountryID equals tblcountry.countryID. Now of course this requires knowing an awful lot about the design and structure of your database, and you can see this information if I go back to my database and just briefly open it up. If I can just get away with opening or showing you something called the database diagram or the relationships diagram, you can hopefully see here that the film table has a film country ID column which is related to the country table based on the country ID column. These lines are designed to point to the correct matching columns. So this is all sort of basic relational database design principles. The idea is that each country name is stored once in the country table, but it's referred to many times in the film table using the ID column, so it avoids having to reuse or rewrite the same piece of information more than once. That's the ultimate aim of relational database design. So I'm just going to close down that database without saving any changes to the design, and having written that code there, if I attempt to run this one now, I ought to find that back in my database I've got access to the country. Oh, I didn't actually add in the country name column, did I? That was the important thing there. So just going back to the VB editor, the really important thing is that rather than having the film country ID, what I do instead is say country name here instead. Now that I've got the country table listed, I've got access to the country name column. I could now change that back in the main routine, the one that generates the pivot table, and say country name. And then finally, if I run the test SQL queries routine again, I ought to find that I do indeed have the country name column available rather than just the ID numbers for the country. Now, joining just two tables together isn't actually all that bad, but if I wanted to join multiple tables together, in Access in particular, that gets a little bit messy. It's not quite as consistently neatly laid out as in a SQL Server equivalent query. But just to give you the basic principles, if I wanted to include, let's say, the certificate table as well, so I could get the certificate name rather than its ID, the best way to approach this is to take your current join, so everything after the word from, wrap that part up in a set of round brackets, a set of parentheses. That represents one successful join. Now, to that pair of join tables, I would also like to now join in the certificate table. So that means, first of all, adding a reference to the certificate table to the start of that from clause, and then saying inner join to the pair of tables that are currently joined together, and then after the parentheses adding in the on part. So I can say here on tbl film dot film certificate ID equals tbl certificate dot certificate ID. It's all a little bit messy, but what that should do now is give me access to the certificate name column, so I could get rid of the certificate ID. I don't really need that anymore, and replace that with certificate name. And then if I go back up to my main routine up here, find out where I've put film certificate ID and replace that with certificate name. Okay, so having done that, if I were to now run this subroutine again, I ought to end up with a new pivot table, but this time showing me the certificate names rather than just their numbers. Now, as we've come this far, we might as well just add in that final table, the studio table. So just as we did before, we've got a successful set of joins joining all these tables together. So the sensible idea at this point is to wrap all that part up in a set of round brackets, a set of parentheses. So just after the from keyword, we can open a set of parentheses, and then right at the end, we can close a set of parentheses. Might make sense to separate these onto multiple different lines at this point, but I'll leave that part up to you. So in the from clause now, we can refer to our TBL studio table, and I want to say inner join to the set of tables that are already joined together. So TBL studio inner join, and then right at the very end of this, after the end of the parentheses, we can add in the on part. So I'm going to say on TBL film dot film studio ID equals TBL studio dot studio ID. Having done that, I can scroll back up to this select list where I'm putting in my column names, and rather than putting in Film Studio ID, I don't need that anymore, I can replace that with Studio Name instead. Then I can scroll up even further, back into my main routine that's building my pivot table, and let's just replace Studio ID or Film Studio ID with Studio Name instead. So, having done all that, back into my test SQL queries routine, give that one more test, and if I quickly look at the results, I've now got access to all my studio names, certificate names, and country names. That's quite a lot of effort to do, of course, and you may well just prefer copying and pasting code from your Access queries, but it's interesting to see what's possible just by writing your SQL queries directly into your VBA code. I think what would just round off this video quite nicely is to create one final version of our main routine up here, which will accept a range of different values, not just the SQL string itself, but the names of the row field, the column field, the page field, the data field, and also which function we'd like to apply. So that's a little bit of effort, and we're not going to learn much more in the way of how pivot tables work. So if you want to stop watching at this point, then please feel free. You're not going to learn any more about how pivot tables and connections themselves work. This is just a few sort of more generic VBA techniques to make things a little bit more dynamic and flexible. So what I'm going to do is declare a few new parameters in this create access SQL routine, and I'm going to say we've got the main SQL string. That's important, of course. I'm going to have the data field as string. That one's going to be compulsory. We must pass in a data field so we can actually see something useful. The row, column and page fields, they're all optional. Well, technically the data field is optional as well, of course. We don't actually need to put any fields into the pivot table at all. If we wanted to, we could make the data field optional as well. In fact, let's just do that. Let's make the data field optional. I'm going to say optional data field as string, which means it will have a default value of an empty string. Then I'm going to have optional row field as string, and that will have an empty string as its default value. Then optional column field, or col field I'll call it, as string, and then finally optional page field as string. We could also add in the an optional function to apply. So if we don't specify otherwise, then it will default to the sum function perhaps. But what we could do here is say optional pivot function, and then let's make this equal to, sorry, I'll spell function properly, putting the fun in function there, pivot function as an Excel consolidation function. So we can use the built-in enumeration there to avoid us having to code that manually. Okay, so what this means is when I want to use this, I need to pass in multiple values. So if I just scroll back down to my test SQL queries, rather than just passing in the SQL string, I can pass in multiple different options here as well. So let's say for my data field, I'm going to pass in film runtime minutes. Sorry, I'll spell that properly eventually. Film runtime minutes. And then a comma, and my row field is going to be, let's go for studio name as usual. And then another comma, my col field I'll make equal to certificate name for the time being. And then we'll have the page field, which will be equal to, let's say, the country name. Again, that's the only remaining field we've got currently, so country name. And then the pivot function we can neatly select from a drop down there, so let's select the average function. Okay, so we can pass all those values into this main routine. What we've got to do now is write the routine in such a way that it will handle all of those different values. To make my life a lot easier here, I'm going to declare another variable which can hold a reference to a pivot field object. So up at the top somewhere in the variable declarations, I'm going to say dim pf as a pivot field. What I can then do is back down towards the bottom, where I'm adding in all my fields. I'm going to change the way that this works completely. So I'm going to take away the bit that adds all of these fields, and I'm going to replace it to start with a test to check if my row fields parameter is an empty string or not. So I'm going to say if, beg your pardon, I'll spell if properly. It's the first time I've ever misspelled if row field equals an empty string, then. Well, actually I don't want to do anything if it's an empty string. If it's not an empty string, what I'd like to try to do is set pf equal to pt.pivotfields, open some parentheses, and then refer to the row field parameter. Once I've done that, I can say pf.orientation equals Excel row field. Then stick in an end if. And that's the same basic approach now to the column field and the page field as well. So if col field is not equal to an empty string, then set pf equals pt.pivotfields, open some parentheses, refer to the col field parameter, and then once I've got a reference to that, I can say pf.orientation equals Excel column field. Stick in an end if. Then, just to avoid having to rewrite that again, I'm going to copy and paste that if statement. So I can say if page field is not equal to an empty string, set the pivot fields to be equal to the page field, and then set its orientation so that it's equal to an Excel page field. I can do a similar thing with the data field, but with the added complication of having to assign the function to it as well. So let's start by testing if data field is not equal to an empty string, then I'm going to set pf equal to pt.pivotfields and then refer to the data field parameter. So exactly the same as we did earlier on. What I can now do is check do as well in the same if statement. I can say pt.addDataField, but rather than referring to this specific field like so, I've already referenced that in the pf variable. I can then apply the correct function. Now I should also test for this because it's an optional parameter. I should test what type of function to use. So what I'll do just for the moment is refer to my pivot function parameter and then say end if, and in fact no, what I'll do is I'll remove the number formatting stuff just for the moment. Just at that point I'd like to give this whole thing a test, making sure that I've passed values to every single parameter. So going back down to my test SQL queries, I'm passing in values to every single parameter, so that should mean that if I were to run this one at this point and have a look back at the Excel workbook, I've essentially got exactly what I've been getting previously for all the other times I've run this with a specific set of fields. I do need to make sure that if I don't pass in a specific function that this will still work. So going back to the VB editor, if I don't pass a function in, it's going to essentially pass a 0 into the main routine. So any number type, any number parameter will accept a 0 if you don't pass a value into it. Now that's kind of okay because the Excel consolidation function enumeration has several items in it with different numbers. If you want to see what those values are, I can head to the View menu and choose Object Browser. Then if I scroll down to find the Excel consolidation function enumeration, which will be in here somewhere, Excel consolidation function, you can see that these are all of the individual values or all of the individual constants in that enumeration. And they've all got numbers assigned to them, but none of these numbers are particularly useful. It doesn't look like. Let's have a quick look. Let's find the sum. Yeah, so they've all got really slightly odd numbers, negative 4,164, etc, etc, etc. So that's quite useful actually. It means that if I haven't passed a particular function name in, then it's not going to match, the 0 is not going to match any of the existing functions. So that's a useful thing to be able to test for. So if I close down the object browser and then head back up to my create access SQL routine, just before I add in the data field, what I'd like to do is check. Let's see, where should I do this? Where's the best place to do this? I guess if I haven't added a data field in, then I don't want to calculate which function to use anyway. So let's say if pivot function equals 0, then pivot function equals Excel sum. So we'll assume that they want the sum as the default value. Another way to test that, or another way to do that by the way, is actually to assign a default value to that parameter. So rather than writing the if statement there, I could have, and probably would be better to do so in this particular example, if I were to scroll up to the functions definition up there, so the subroutines definition, optional pivot function as Excel consolidation function, I could make that equal to Excel sum. Excuse me, I'll find Excel sum in there. There it is. So that would assign sum as the default value anyway, so I don't have to make this little test. Entirely up to you which way around you'd like to check for that. If I just comment out the if statement that I've written in there first, and then head back and remove the call to the or the average function in there, run that subroutine one more time, and I ought to find that this time I get a new subroutine which is giving me the sum of runtime minutes because that was the default value. That would work equally well, as I say, if I go back up to the definition of the method and, sorry, beg your pardon, if I go back up to the definition and if I change the default value and then test for it explicitly in the rest of the code, I'll bring that if statement back in. If I run the test SQL queries routine one more time, I will once again end up with the sum of runtime minutes because the default value passed in was 0. So your choice on how you could handle that. We should also check that we can happily change the way the the pivot table is generated, if I say, let's say I wanted to find out the sum of runtime minutes for each country in the database, then I could take away the reference to the studio name and certificate name there. So that's passing the SQL string into the SQL string parameter. Data field will be film runtime minutes, and the row field will be the country name. So, having done all that, if I were to just execute that subroutine again, I ought to end up with a completely different pivot table this time. So this one doesn't have any column fields or page fields, it just has a row field and a data field, which you can see there. So it's a reasonably flexible query, or reasonably flexible procedure at this point. It means I can pass in any combination of valid names and create a pivot table based on what I want. One final potential source of error that it's well worth considering here is what happens if you try to refer to a column name which doesn't exist in your underlying query, or maybe you mistype a column name, for instance. So if I typed in country NAM, for instance, and then tried to execute that subroutine, I'd end up with just a simple runtime error dialog box. If I click debug, then of course the line that's throwing the error is the one in which I'm trying to reference this non-existent column name. So it depends on how much effort you really want to put in here, I suppose, as to how much code you write. Just as a really simple level, all I would need to do here is write something basic like on error go to wrong name, and then I can just copy that label and then paste it in down at the bottom of this subroutine, and then type in a colon after its name. I want to make sure that I exit the subroutine before I can reach my little error handling section as well. Again, there's a video that explains error handling in a lot more detail that's part of this main series, so if you need any more detail than this, we're just covering the absolute basics here, then do feel free to have a look at that other video as well. So all I'm going to do here is display a message box that tells the user that, wrong column name, and then I'll have a VB critical symbol on there as well. So the end result of all that is, if I were to run the original subroutine, the test SQL queries routine, passing in the wrong column name, it will tell me that I passed in the wrong column name. And I can click OK, and then the thing will just end, so it avoids the user breaking into the code. So I am still left with a pivot table here, of course, and if I have a quick look at that, I could then choose to put in the columns myself. But we could add more error handling code here, of course, to delete the pivot table, and so on and so on and so on. It depends on how much stuff you really want to do. So we could then just make a quick call to the delete all sheets and delete all connections routine in the error handler. As I say, entirely up to you at this point, but there's a quick basic overview of how you might approach that. If you like what you've seen here, why not head over to the WiseOwl website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.